Well, hello everyone and welcome back to Adrian's Digital Basement 2. Today is a super mini mail call episode and I'm trying to get through the big pile of boxes that I got back there. And this one is going to be next. This one here comes from Steven in North Dakota. Hi to all my North Dakota viewers. We got lots of paper packing material. Good, it will all go into the recycle bin. And we got a note here. Adrian, here are the genuine Apple parts I emailed you about. I was working at a former authorized Apple service center that was cleaning out their attic in 2010. Employees were given the opportunity to claim any of the items that were bound for recycling. Since I have a couple of Apple IIgs machines from the late 80s and 90s, I grabbed the IIgs related stuff. I stored these in my garage over a dozen years without using them, and after falling into Adrian's digital basement rabbit hole recently, I decided it'd be better served in the care of someone who might actually have a use for them. I'm not sure if these are new old stock or if they are bad parts that were destined to be returned to Apple for refurbishing. I really enjoy your videos and often learn something new along the way. Steve. All right, awesome. Thank you, Steve. So yeah, remember that conversation we had, and look at that. We got Apple Service Center boxes. So let me extricate everything from here, and let's see what exactly we have in here. I recently had, well, it wasn't so recent, there was a video, I think on the second channel, maybe it was on the main channel, where I had a bunch of Apple Service Center parts. None of those were Apple II, or I don't think any were Apple II. They were all for the Macintosh. But there was some cool new old stock stuff like power supplies for Apple II or Mac Pluses, SEs. I think there was a logic board or two and a few other things. But this looks like it could be a motherboard here. So let's move this out of the way and we'll go through these packages. All right, we'll start with this smaller box. I'll leave the one that looks like a motherboard for last. Here we go. This says Apple Service, Apple IIgs Memory Expansion. CD? Compact disc? I don't know. I doubt that. It's probably one of those RAM expansion cards. And looks like it's been opened. So maybe this is a bad part that had to go back to Apple and was never sent in. Just, one of the standard Apple IIgs expansion cards. I think this card can hold 1 megabyte, which would bring a regular ROM 0 or 1 machine up to 1.25 megabytes. There were other cards made by other companies that could hold up to 8 megs. In fact, I have a modern one in my IIgs. I think it's a 4 megabyte one, and it's literally this big. It has like one 4 meg SRAM chip and a little glue logic, and that is it. And indeed, these are 256K chips, so 8 of them equals 256K, meaning that this card is good for 1 meg total. As far as I'm aware, every single Apple IIgs came with one of those cards inside the machine, so they're very, very plentiful. If you look online, they're pretty common. Okay, Apple IIe card. What's this? That's kind of interesting. Oh, wow, this is one of those cards for, I think it's for the Mac LC, or, yeah. So this is the entire Apple IIe card that goes into a Mac to make it compatible. And it's got a couple caps on here that I will need to change, but this is the Mega 2, I think it's called, which is essentially the same chip that's in the IIgs that gives the IIgs 100% Apple II compatibility. This chip here, this large LSI chip, is the entire Apple II on a chip. And yeah, I mean, the worst thing about these cards is this connector here. It's kind of a non-standard thing. You can buy them, but there was a cable that plugged into this and then would split out to the Apple standard Apple II floppy drive and maybe the joystick ports, something like that. Now, I do have one of these cards that I have yet to test, and so yeah, I won't be able to test this now because that card is not easily accessible right now, not to mention I gotta grab my Color Classic 2. That's the only machine I have that could actually run this, and I think you need to patch something on that because I have like the LC575 motherboard in there, so I'd have to patch something so that this can work. But at the minimum, I'm gonna take these caps off right now, and that's gonna make people squirm. And the way I'm gonna do it is twist them off, and I can actually see that one leaking right there. There's actually, let's zoom up here. Oops, wrong way. You can see there, you see it's a little wet. it's actually leaking. This is gonna make people freak out, but that's how I do it. I just grab it, push down, and pull it off. And I've done that a billion times without any issues. And when it's corroded like that, you're not gonna be able to desolder it properly. So I'd just rather get these off the board than leave them on there to keep corroding. This is the same thing. Grab it, push down, and I just start twisting. And eventually, whoop, there it is, falls right off. And yeah, there are the little legs it left behind. You just sort of can wobble those off with your finger or a little tool or whatever, and there we go. Those came off. And as you can see, the legs are left behind, no damage to the board at all. Now, I'm not telling you to do the decapping that way. It might damage your board. Mileage may vary. You can look online and there's a billion opinions. Opinions about removing caps are like belly buttons. Everyone's got one. And, well, oh, my trash can is covered with boxes right now. That's just the way I do it. So what I'm gonna do right now is we're just gonna spray a little IPA on here, just to kind of rinse off the cap juice that was leaking on there. It'd be sweet if in these boxes was the cable too. That would be absolutely freaking fantastic. Let's wipe up this mess here. There we go. All right, next up, Apple IIe mouse. What exactly is a IIe mouse? I guess it's like the 2C mouse. I need a little, this one's unopened. Well, the tape here is sealed. Is this like the 2E or the 2C mice, I mean, but the color is Apple IIe style? Maybe. Oh no, it's a mouse card. Oh, that's what CD stands for. All right, and look, this thing is brand new old stock. Well, I don't even need to open this. Yeah, so an Apple IIe mouse card. Now, very lucky, these aren't super common. I am lucky to have, I think, one of these, just one. So that's pretty darn sweet. What a great save that this was about to be recycled. Okay, this thing here, there's something wrapped in plastic. Is this a keyboard or something? I'm guessing this is like a 2E keyboard, like a new old stock one. No, it's not. It's some kind of a card, and another card, and another card. Okay, so I think these are, so it's like a PC card. Okay, it's a Cirrus Logic, pretty run-of-the-mill VGA card there. All right, definitely didn't come from the Apple dealer. I don't think they would have one of those. This looks like a 3Com ISA network card. Always very, very handy. There it is, perfect condition, totally dust-free. I don't even know if this has ever been used. I don't see any marks. You can often see witness marks when you plug these cards into slots. That one has none. All right, what is this? Something with a fan and a heat sink on it, this large card here. Is this like a new bus card or? I don't even, no, this is an ISA card of some kind. What the heck is this? I don't even have the faintest idea what this is. Well, this card is interesting. Tons of I/O. Oh, you know what? There were some large cables that were included right here. These are clearly the cables for this. Well, what does it say here? Motion server, Rev C. Okay. We got, I don't know what these chips do. And we look over here, and we have static RAM here, 15 nanoseconds, some flash memory, an EPROM, and some kind of chip, which, I mean, it's got the pinout to be possibly, is that like a 486? Could a 486 be that chip? I mean, I don't even know. I have no clue. And down here it says axis 13 to 16, 9 to 12, 5 to 8, 1 to 4. Axis. Like, is this for controlling motion cameras for motion picture use? And is this like a 486 processor that handles that, like as a code processor? Whatever this is, it's purple ceramic. You know what? Let me just get that out of there, because if it's an Intel chip, we should be able to see that on the bottom. Let's see if the Intel official tool, oh, look at that. It's actually working. Amazing. So this is the little tool they give you with the overdrive chips to help get stuff out. It doesn't work great when there's no clearance like there isn't on this. So I'm gonna have to do the old screwdriver thing, and I know people are gonna cringe because you can crack the ceramic, but there we go. No, I don't think that's some kind of Intel chip because there's no marking at all on the bottom. It's just completely blank. So who the heck knows what that is? We'll just push that back into the board. Mystery ISA card. All right, well, there are these big cables that my assumption is they go with that mystery card. So if you know what that card is, then let me know. Otherwise, I guess I'll just be able to reuse that cable for projects. Has this one been opened? I can't remember. No, this has not been opened. This one says it's a 64K RAM expansion for a 2E and 80 column card. And it's a little tiny baby one. I forgot that they got this small near the end. Let's pop this out of here. Yep, they just shrunk it down to the bare minimum. So we have 64K as 2 chips here. And well, let me look at what these are here. 74 LS245. It's a latch, a 374. And then we have an LS14. That's all it takes. Now, the earlier ones were bigger because they used 1-bit wide RAM chips. So you had 8 RAM chips on there, plus probably the same 3 chips. But in the end, that's all you really need to expand your 2E. And it's pretty funny that this wasn't just included on the motherboard, but I guess it was a way to like somehow save cost. Even though later versions of the 2E should have just had it on the board. Like, I don't know. They probably kept it, to be honest, because there were other cards that could go in here to add more RAM, like add extra RAM. Or I think there were 80 column cards, or not 80 columns, RGB cards that plugged into the same slot. So to keep compatibility, they kept that. All right, next up is this, another 2GS RAM expansion card, which is right here. And this one appears to have an additional set of memory. Nope, it does not. This is exactly like the other one. So 256K, 1 megabyte total, and these are terrible sockets. I absolutely hate those sockets. In fact, is that what we got on the other one too? Yes, we have on the other one, the same crap sockets. They're just junk. And then lastly, we have the last big box. It says MLB A2GS 1 megabyte. Is this a ROM 3 motherboard? I think it might be, if that's what's actually in there. So let's take a look. Okay, yeah, so Apple 2GS with 1 megabyte of RAM, EFI foam installation. Interesting, it's sort of like stuck to the paper here. Okay, but still has it looks like it has the adhesive, so you could peel that off. So it says here, per FCC requirements, 2GS with 1 meg of RAM requires EMI shielding foam around the I/O ports. Apple must have got busted for that. Please remove the old EMI foam and install the new foam. Okay, and there's a 2GS case. So it's not like this is one of those super ultra rare Apple IIe upgrades, because that would be sweet. So this one obviously has been touched. So maybe this is a bad motherboard that is supposed to go back to Apple. But indeed, we have a ROM 3 board, I'm pretty sure. And I'm not totally up to date on my 2GS stuff, but I think the difference is the ROM 3, the 1 megabyte ROM 3. The original 2GS only has 256K. This machine has a battery in a battery holder. So let's right away just get that off of here, because we don't need no stinking leaky battery. That has not leaked. Excellent. So that's a good thing. And there are no SMD caps on this thing, so there's nothing really to go bad. Let's see if that battery's got any life left in it. It may. It's possible. Let's see here. Nope, that is dead as a freaking doornail. All right, so the ROM 3 boards are, well, the last revision of the 2GS. They're not faster in any way. They just have 1 meg of RAM on them, and then the ROMs, I think, are double the size. And what they did is they took some of the routines that are normally in the GSOS, that's the graphical operating system for the 2GS, that have to load off disk, and they put them in the ROMs. I don't know, though, if you have like the later, newer versions of the GSOS, does it still load those into RAM? Or do you get the benefit of these additional ROM-based routines, which supposedly, when this board came out, it sped up the booting process into GSOS, which on 3.5-inch floppies was pretty slow. Let's be honest here. And this thing, which is a 65C816 processor, ran at a paltry 2.8 megahertz, so super slow. And really, that hamstrung the 2GS from being a much more capable successor to the Apple II line. If this thing ran at 8 megahertz, like it probably should have right from the start, even with the unaccelerated graphics and whatnot that are on here, this thing would have had significantly more capabilities in the high-res modes, because the 65C816 running at 8 megahertz in 16-bit mode is kind of, I wouldn't say it's equivalent to a 68,000, but it's probably as fast, at least at certain routines. So pushing pixels around for the graphics and stuff like that, it probably would have felt much more like the Atari ST, which is also using the CPU to push all the pixels around. It doesn't have acceleration like the Amiga does. But, you know, the rumor is Steve Jobs didn't want the processor to be too fast to encroach on the Macintosh. I don't know what the reality is there. Whatever the reason, it's slow, and that's unfortunate. So I think what I need to do is grab an Apple IIgs and take the power supply out so we can test this motherboard out, see if it actually works. And we can also try those RAM cards, I suppose. Although I don't know if the built-in diagnostic routine on this thing will test the RAM on these cards. I'm holding them in a way that you can't see them. These two cards. These plug in, incidentally, right here into the motherboard, into that slot. So they go like this. And in this computer, when you add one of these cards without any additional RAM, you get 1.25 megabytes, and obviously fully populated, we get 2 megabytes. And as I mentioned before, I think this computer can support theoretically up to 16 megabytes in this RAM expansion slot here. There is no need for the mouse card on the 2GS because, of course, the Apple IIgs has ADB. I think it's that port right there, Apple Desktop Bus, which allows you to use any Macintosh keyboard, mouse, things like that. Those all work interchangeably with the 2GS. In fact, the ADB port originated on the 2GS first because at the time, the Mac Plus was out and that had normal 9-pin mouse connector and keyboard looked like a phone jack. ADB came out on this in 1986, and I think it was 87 or thereabouts where the Mac SE came out, which was the first machine to have the ADB port, and then Mac 2, and then, a whole bunch of machines after that. But, they were using that well into, I don't know, the PowerPC time, when USB finally took over for all those types of peripherals. Then that port did finally go the way of the dodo. All right, so let me go grab a 2GS power supply so we can do just a quick little bit of testing. All righty, here's the Apple IIgs power supply. I grabbed it out of one of my working 2GSs. I do have to wonder if this has got RIFAs in it. Most of these do, and I don't really feel like having a RIFA explosion here. Well, I think we're gonna leave dangerously and we're gonna try this out and see if this motherboard works. Now, earlier 2GS motherboards, the ROM 0 and the ROM 1 versions, actually have a footprint for an Apple IIe power connector as well. So theoretically, well, you could use a 2E power supply. I don't know if it actually fit in the 2GS. This one has a little notch right here, which actually is clipped into the case, is what holds the power supply in. But this one, they got rid of that extra footprint. So all we have is the 2GS specific power connector here. I was looking through a pile of speakers so I could hook something up, and here's something that should work. It's a 2-pin connector. The reason why this matters is there's a beep when you first turn on the 2GS. So even without video, we can actually hear if at least it's posting. I don't know, maybe that's not the right term, but if we hear a beep, there's something happening here. All right, here we go. Nope. So we have, oh, it did work. Okay, I talked over the beep, but the power LED is on here. Let's try that again. I don't know why that took so long to beep. Okay, beep twice, that's normal. You get one beep for the original startup sound, and then you have another beep to say there's no disk drive found. Alrighty, the open source scan converter has been fired up, and I have it connected up to the 2GS motherboard here. We'll power this on. Yep, this is normal, the no signal. Should just take a second here. There it is. Well, this thing appears to be working. Why was it in the box? Was this like someone had opened the bag, looked at it, put it back? Was this like new old stock, or this is new old stock that was supposed to go into a 2GS in for repair? Who knows? I went and grabbed a keyboard and mouse so we can plug it into this thing. Of course, this is not the original Apple IIgs keyboard and mouse, but that's okay. As long as it's ADB, it will work perfectly. All right, so we hit Control Reset here, and that does work. Control Open Apple Escape goes to the control panel. We can manipulate the volume and the pitch. In here is where you have the system speed, 2.8 megahertz, or the old 1.0 megahertz. Now, on the keyboard, if you hit the Open Apple, Closed Apple, or the Option and the Command key, if you're using a Macintosh keyboard, and you hit Control and you hit Reset, I think that should go into a diagnostic mode. And yeah, here it goes, diagnostics. And we're seeing a little bit color because when you're using the composite output on the 2GS, it does output a color burst signal, a color signal, while the graphics modes are enabled. In text modes, though, you're always going to get grayscale. Even though if you go to the control panel, there are ways to manipulate the background color and stuff, you're just going to get shades of gray, and that is on all the 2GS motherboards. I don't know how comprehensive this particular RAM test is. I don't have the RAM cards plugged in, but at the minimum, we're gonna know if the onboard memory on this machine, which is a megabyte, is okay. I think it tests all 1 megabyte. So I presume that this diagnostic test runs a lot slower than the version on the ROM 0 and the ROM 1 motherboard, which only has 256K. System good. All right, well, that's awesome news. I think we're gonna do a little bit further testing. I have the floppy EMU here, and I'm gonna plug that in because I've downloaded a RAM test onto my floppy EMU here. And let's see if it is, and if it is, we'll stick one of these cards in here. I've never tried any of these tests before, but I'm kind of glad to have finally, oh, nice. All right. Programmed by, oh, I was about to read the name of the author there. Oh, this is 80 columns, and it's very hard to read on the composite output here. If we switch to component, that should give us better visibility, and it does. Okay. All right, so look at that. 2GS ROM 3, built-in RAM, 1024K, no expansion memory, start end bank, 0 to 0. Well, I don't even know what the end bank is. Looks like the default start end banks are detected memory expansion. Okay, so there is no memory expansion, so let's pop one of these cards in here. There we go, and let's reboot the computer. Is it gonna boot back up? Yes, I think it is. All right, there it is. Expansion RAM, 256K. Looks like various tests are possible. Bitwalk, random. So no March test, unless that's what Bitwalk is. So we'll try Bitwalk. There we go, begin test, spacebar, enter. There we go, now it's running. Full manual and latest version available here on GitHub. Yeah, there's a link there to that if you want to download this and try it out yourself. So the software is only testing the expansion card because that diagnostic we ran earlier by holding down the Open Apple, Closed Apple, I think tests all the motherboard RAM relatively effectively, I think. If anyone has ever disassembled the Apple IIgs ROMs to look at what kind of memory test it's actually running with the built-in diagnostics, I'd love to hear. Is it just simple pattern testing? Is there actual March testing going on? I'm assuming because it was written in the 80s, it's probably just simple pattern testing, which, you know, is okay. It's going to find some errors, but it's definitely not going to catch the more subtle errors. Now, the way the extra memory works on this particular processor is, remember, it is a 6502 at heart, and that means it has 64K memory banks. So it has a page register, which has up to FF pages of 64K, and I think that's where you get the 16 megabytes of RAM that is possible on this particular CPU. All right, well, it looks like it's at pass 3. Now, this is only a Bitwalk test, so it's not as good as a March test, but it's still better than a pattern test, I would say, at least. And that pretty much confirms that this first memory card is all good. So everyone knows what that means. This gets a little tick mark here to indicate that it is currently in a good state. Let's go to this second card here. Also, I'm pretty sure that this 2GS itself is in a good state, so I'm going to draw a check mark somewhere on here, just in a place that's in a blank spot, like over here. And along the bottom edge here, I'm just going to write Steve, because I just like to know exactly who these parts come from. All right, second card, we're going to do the Bitwalk again, and we're going to start the test. Looks like there's some other options for iterations and refresh pause. Refresh pause allows the RAM test to just sit there idle for a little while, and that's checking for refresh problems. If your RAM is not being refreshed correctly by the logic that's on this card here, I don't know if it's coming from the motherboard or this stuff here, then what happens is you'll have some bit decay in the chips. They'll start to lose bits, and then that'll show up when it pauses. And taking a look at the logic that's on this card, this stuff is just some simple 74LS logic. There's no way that the refresh is happening on this card, so it must be coming from the motherboard itself. At least that's my hunch. All right, looks like it's on the second iteration of the RAM test, so this card is good as well. Oh, so it gets a tick mark as well. I'm just gonna write Steve up here on the top edge. And that's it for the 2GS peripherals. These cards are good. The motherboard appears to be completely good. And really, all that's left is this Apple II mouse card. I'm not going to test this because it's still sealed. And in case you are wondering, to use this on an Apple II, you need to use an Apple IIc mouse, or some Macintosh mice, the old 9-pin variants, will work perfectly. And this gives your Apple IIe, or theoretically, I guess your 2 Plus as well, mouse capabilities. Although most software that uses the mouse requires double high res, and that means that that's not going to run on 2 Plus. That will only run on 2E or like a 2GS or whatever. But you don't need a mouse card here because, of course, we have ADB. But this is all to say you couldn't use this card on the 2GS in slot 4. And then you could use an Apple IIe mouse if you so desire. One last thing, I'm just going to quickly add 2 new capacitors back to this board so it's just done. First step is to get off the little legs that are left behind on here. So just a little solder there gets that off. Definitely these were leaking. You get a little bit of fish smell. And with the little leg remnants removed, we're just going to use a little bit of braid here to clean off those pads, get off that crusty, corrosion-ridden solder that's on there. Now these pads over here cleaned up well, but there's a little bit of leftover junk on these, so I'm just gonna try to retin these here. And notice here, there's some corroded part of the pad that the solder is not sticking to. And what I will often do is just use some tweezers just to lightly scratch it, just to kind of clear up any of that corrosion that might be stuck and left over on the pad. Okay, that looks a little bit better. Now all this is just flux residue, so nothing to worry about there. Just add a little bit of flux, and this is the capacitor I'm going to be using. It's a little ceramic capacitor. And the same thing over here, I'll just put a little flux there, and we'll put this little ceramic capacitor on here, and just move it around so it kind of sucks up that flux. That will help us in the soldering. So these caps are 22 microfarad. So I'm just going to go, whoops. That's not what I intended to do. So yeah, these caps, as I was saying, they're 22 microfarad, and there's one, and the other one, we'll just put a little solder on the tip here, position it. These are a bit smaller than the original. Whoops, moving around there. One side, and we'll do the other side. And the good thing about these types of caps here is they will never leak, these ceramic types. All right, there we go. It's a little bit messy. I just need to clean up that flux. So I'm just gonna tilt the board over here, 99% isopropyl. And you can kind of see that this is the flux that's coming off the board there. So it definitely is cleaning it up a little bit. And there we have it. One Apple II emulation card for the Macintosh with 2 new ceramic 22 microfarad caps. That should never leak and should work, well, pretty much forever until this stuff still starts to fail. So there we go. Steve, thank you very much for rescuing all this Apple IIgs stuff. It's really cool to know that the motherboard and these RAM cards just completely worked, and I'm gonna have to assume that this card is gonna work as well, plus the other ones we haven't tested. And if anyone, again, knows what this card is, please let me know. Not sure it's particularly useful for me, but some kind of motion capture camera control board for Hollywood movie production or something like that. When it comes to this Apple II card here, I'll have to do a test and try video, a separate video on the second channel probably, where I try this thing out. So if you have the right details on how to get this working in a color classic with the LC575 motherboard in it with the 040 processor, definitely let me know. And again, the cable situation, yeah, it kind of sucks that there's no cable, because that's the hardest thing to find for these. So yeah, that's really cool. Steve, thank you very much for saving this stuff and holding on to it all those years and then sending it over to me in the basement. I really, really appreciate it. All right, let's keep this train moving. I have another box here. It says Handtech on the side, but it's not something I ordered. So let's see what's in here. This box comes from my viewer, Jeffrey, in Hampton, Virginia. Hi to all my Virginia viewers. And in the box, it says Commodore chips. Let's take a look at these Commodore chips. I love Commodore chips. We always know we're doing fixes on the channel here. There's always a plethora of 64s that need fixing, and therefore chips are always useful. All right, there we go. All right, so 6522, a 6567 R8, that's a VIC-2 chip. We have another VIC-2 chip, one of the old 6As from the original one. An 8722, which is what? That's got to be from an Amiga, I suppose. I'm going to have to look some of these up. 8360, 8501, that's a 6502 CPU. Is this the one from the TED machines, or is this from the short boards? I can't remember if it's an 01 or 02. And then we have a 5710. We have a couple 6526s. Oh, we have more than that. We have 3 of them. That's awesome. A Commodore 64 CPU there, another one there, and another 6526. So that's awesome. 4 of the 6526s, which are the hard ones to find because they do get blown out when you get static charge, I guess, into the joystick port, for instance. Okay, so let me just quickly go through what these chips are. This is the C128 MMU. The 8360, this is a TED chip, so it's the main graphics sound chip for the like Commodore C16 and plus 4. And then this right here is the CPU for the TED line of machines, or the is this called 264 type machines, and these chips are always dead. Essentially what I'm doing right now is I'm just trying to look up what these chips are here. Does this tell us what this is? Oh, accept all, okay. Says here that this chip here, 5710, is the complex interface adapter for that C128 DCR. Why does it say 6526A? I mean, that's clearly not what this is. It's a 48-pin chip. But what we're looking at here definitely matches, so okay. I'm going to put C128 CIA, I guess. I don't know. And as far as the rest of these go, I think I know what everything is. Yep, all that stuff is completely known. All right, well, let's just do some quick testing here. So we're gonna grab the old Ziff 64 here. Don't need the keyboard. All right, and with the hardness plugged in, this is all just the stock chips. Just make sure the system is working. And now I'm just gonna quickly go through and test these chips here. And once I get a clean pass on my machine in stock configuration, kernel ROM bad, okay, that's fine. All right, I think we're all good. Interrupt, okay, there we go, we're all good. Now I'm just gonna go through and test each one of these chips, all the 64 ones that is. Just make sure we're all good. Now I've talked about this before, but just in case, if you don't have the full test harness and you're testing 6526 chips, what you can do is look at the clock down at the bottom there. See there's 2 times, 11 a.m. and 16 p.m. Well, those need to be good and working. If the chip is bad or not working at all, not talking on the bus, you're gonna get garbage in that location right there. All right, we got our first good 6526. I could speed up my testing here by using that other socket next to it. And in fact, I should probably be testing the video chips as well. And we can test out the CPU on top of that. Okay, here we go. So far, so good. I can switch the input to composite just to make sure we're getting the right colors. There we go. All right, so the CPU is definitely good. VIC chip seems good. And we got a good 6526. All right, the next 6526, 6510, and the VIC is in the machine. And the colors are gonna look weird on this VIC chip because it has less luminance levels than the regular R8, because it's the earlier one. And you get a little bit more color fringing. If you notice around the text, it doesn't quite look as good. And that's strictly due to this ceramic early R6A version. And it looks like we are all good. We have another good VIC, another good CPU, and another good 6526. All right, I have the last untested 6526 in here along with the original CPU and VIC. And what did I do here? Oh dear. I just put my 6526 into there. That would have killed it. That would have killed it. And I did that because I forgot I was using the Kawari in here. So the original VIC chip wasn't in there. That would have just give 12 volts to this chip. Oh, you know, I haven't done something that boneheaded in a while. Let's just see if this chip is indeed completely fried. I'm sure it is. There is no way it survived what I just did to it. But I guess anything is possible. Maybe that particular chip is, or that pin is somehow not used or something. I don't know. I mean, the time is correct, so it's partially working. It'd be some kind of a miracle if it still works. Oh, yeah, boneheaded move. I mean, I'm very lucky. We have some new chips right here, so I have another 6526 thanks to the generosity of my viewers, but do not do that kind of thing. Oh, man. It works. It freaking works. How is it possible that chip survived being in the socket here? That socket gives 12 volts to that chip on one of those pins, and somehow it's fine. I am flabbergasted that chip here survived that. Maybe because I only turned it on for a second. I don't know. Wow. Absolutely wow. All right, well, let me go back to the chip I was trying to test. This one right here. Let's see what happens. I don't know how many times I've dodged a bullet by putting the chip in the wrong way. Like I've had it reversed in the socket and it has survived. And like that, I don't even know how that's possible. It survived and this chip is good as well. So very, very lucky there. Maybe I should go buy a lottery ticket or something like that. All right, we're done with the ZIF 64. And now I'm bringing in the Commodore 16 here, which actually I had the screws off it already. Oh, this is my one that has the whole clock mod thing. You know what, to be honest, this is all super unreliable. So I wouldn't be surprised if this machine doesn't even work right now. Oh, and this LED is like hardwired on here. And the thing that's annoying about the C16 is it doesn't use the normal Commodore 64 power supply. It's like a DC barrel jack. And I have the power supply floating around here somewhere, but I don't know where. So we're gonna have to use the bench supply to power this up. And I do know that I think this thing uses like reverse polarity or something strange like that. Very annoying, Commodore, very annoying. All right, so we're gonna use the multimeter here. I clipped onto the shield there. Let's see which of these is ground. Yeah, see, it's the positive lead, which is the center pin. All right, bench supply is hooked up with the polarity reversed. I'm gonna set the supply to 9 volts. I think that's generally what this thing needs. And I'm gonna use my VIC-20 video cable adapter here to plug in the composite output here. So plug it in there. And what's happening here? I don't know, there's a bunch of weird stuff. So the PLA has been replaced. I think this is Daniel's project here, Daniel Mantioni's. Let's just see if this thing even works. Oh, I was like, there's nothing, but that's because the bench supply is not on. What's happening here? Is the power switch gone bad on this thing? Or is it that this DC barrel jack is not the right size? I bet you it's that. Really? Yep, there we go. Okay, I pushed down on it and it turned on and it actually is a working system. I don't know if those colors are right, but it works. And this whole thing here allows me to change between PAL and NTSC by holding the reset button down, if I recall. No, how does this work? How do I switch? Oh, yes. Maybe? Oh yeah, there we go. Okay. So I made a video about this, which if I remember, I'll link down below, but it's an Arduino. And there are 2 different kernel ROMs on here. And luckily on this particular machine, the only thing that changes between PAL and NTSC is the kernel and the clock crystal. So the clock has been bypassed, and this is a clock synthesizer here that is generating the clock signal for the machine. The Arduino is controlling that, and then it then also selects which kernel ROM is in use. The video chip, which is I think under this heat sinks thing here, the TED chip, it can switch on the fly between NTSC and PAL, and it's programmed by the kernel ROM. So with this machine, if I just push reset quickly, you just get a normal reset. But if I hold this down for a second, I think what happens is the power LED blinks, there it is, and I let go, and you wait a second, and then what happens is the Arduino resets the computer, switches the kernel ROM, and reprograms the synthesizer there, and there you go. Now we're back in NTSC mode. And this machine has 65K of RAM because I have upgraded the RAM as well. 64K is RAM, 64K. So yeah, this is my little hacky hack Commodore 16. I love it because it's good for both things. There's some notes here to remind me what's going on. And the reason why I thought it might not work originally is because these DuPont type connectors that I'm using on here are super flaky. Not the original good quality ones, but the cheap Chinese cables you buy are just suck. So it looks like I've actually gone ahead and soldered all of these wires on, and that's because this was all super unreliable. So this stuff is all soldered, and the only thing that's not, I think, is the LED for the case. And you can see the LED right there. And here's what I was talking about. You hold down the reset button, and the light will flash once. There we go, twice. That's gonna say it's gonna run in PAL mode, and it will flash one time if it's gonna go into NTSC. And I think it's gonna go to PAL, or not. I think this is the RetroTink doing its thing. Let's try again. Oh, come on. I think what's happening here is the RetroTink is being obstinate, as it always is. I don't get this thing. How could it be so unreliable? It's such an expensive device. I think it's designed for game consoles and stuff, and it just doesn't work well with retro computers like this. Or we broke the machine. Is that possible? Come on, are you kidding me? Yeah, not working anymore? It says no signal, so it's like detecting something. Oh, and now it's in black and white? What? Oh yeah, I forgot. Every time you power cycle this thing, it actually changes into composite, or it goes off composite, goes back to YPBR. Okay, anyways, the machine is working. That's what I just wanted to make sure, that we have a good working machine so I can test out the CPU and the TED here that was sent in. So let's power this off. We'll start with the CPU right here. Now, one thing I will warn you about is that the sockets in use on this machine are junk. And typically, yep, I've already changed that one out because I think I was fooling around with the CPU or whatever, and it basically killed the socket. And then once that happens, the whole machine was incredibly unreliable. All right, so just checking everything looks good on here. And let's just double check. This is actually the CPU 8501, and the one that was in here is also an 8501. These chips, by the way, the CPU specifically, is extremely, extremely unreliable. So I will not be surprised if this CPU is dead. Maybe it's good. Ah, it freaking works. Unbelievable. All right. Well, we'll put a tick mark on there because that is freaking awesome. I think I have several of these machines, and many of them have bad CPUs. Now, I did do a video at one point about using a CPU from Commodore 64 and then doing the kernel mod to allow it to work, and you have a little interposer board. But there's also Daniel Mantione, who made that Gal-Pal PLA thing, which I think is, this is his right here. He made a 6502 replacement. So you can use a regular 6502 in here, and there's a little board underneath, and that board will create the extra signals, the extra capabilities this chip has that this machine needs to work. It's that first address, 0000. There's a port there, IO port. So his little board does that with a regular 6502. So you can get standard 6502s from, you know, anywhere else. You know, there's tons of those around, and then it will work in this machine. Daniel actually sent me one of those, and I hadn't gotten around to testing it, but you know what? Might as well now that we have this thing on the bench. Let me go grab that. All right, next up, we have a package from the Netherlands. Hi to all my Dutch viewers. This one comes from Daniel, and this is the same man who created the Gal PLA project. So if you haven't watched that video, I'll put a link in the description. But essentially, he came up with an open source project where you can replace a Commodore 64 PLA using two very inexpensive Gal chips, which you can get. They're not manufactured anymore, but you can still find them very easily, and a simple PCB, and that gives you a replacement PLA chip for your 64 for just a couple dollars if you build like 10 of them. So Daniel likes to make projects all the time. He actually sent me some other stuff in the past, like a little ROM adapter board for the 64 as well. So it looks like he has gone ahead and done the same thing now. So there's a bunch of neat stuff here. Wow, look at all this. Oh yeah, lots and lots of goodies. Okay, well, first off, I have to go straight to the candy that he has sent. So this looks like some chocolate, some Dutch chocolates, I guess. Let's get the tape off of these. So these maybe look like little hard candy chocolates. Not totally sure. I haven't tried these before. I have been to the Netherlands before. So I did try as much candy as I could get my hands on when I was there, but I don't think I tried these. They look interesting. Let's try. Oh, that is really good. It's got a crunchy kind of, almost like a biscuit, like a cookie kind of crunchy texture wrapped in chocolate, has a nice toasted flavor. Those are absolutely delicious. Maybe a little bit of ginger. Yeah, it's definitely got some ginger in there. It's a little bit of a ginger snap thing going on. And ginger snaps. I love things with ginger, and I love ginger snaps. So these are fast. These are so good. They are not gonna last. I'm gonna eat these so fast. And I think my blood sugar is actually low right now. So it's perfect that these arrived so I can eat these. All right, so besides this amazing candy, he did send some projects here. Some of them are really, really cool projects. So the first one here is the Commodore 64 PLA replacement project, the GAL PLA, but Model B, which looks to me like it's size reduced, so it's slightly smaller. Next up, he has one that says MOS 6259 replacement, MOS 6259 replacement. Do I know what that chip even is? I'm not even sure what chip that is. He probably explains it in the letter here. And then the next thing he sent here, which I peeled the label off accidentally, it is the Commodore 16/116/+4 PLA replacement project. And this appears to use GAL 16 V8 chips. So the Commodore 64 version uses the 20 V8. I guess this one has a little bit less going on, or he's simplified it or done something. I'm just kind of looking at the PCB in here, but I guess he's using the different GAL chips. So that's cool. So another awesome replacement project. So really the main attraction of what he has sent is this. Now he has it all sort of taped together, but right there, 8501 CPU replacement. It's got some SMD parts here. Looks like he's got some surface mount chips. I think these are bus transceivers, different versions, some more SMD stuff. He has gone ahead and sent me some nice sockets, 2 different types here, and then some PCBs. Actually, that's something else. These are the PCBs here. So what the 8501 CPU is, it's the CPU that's used in the Commodore Plus/4, the C16, and the 116. And it is an extremely high failure prone part. Very hard to find now because they only made the chips for those computers and all of them are dying. So when you go look online to try to buy one, it's next to impossible. And unfortunately, it's a different part than the 6510 using a 64. Those are much more reliable. And it's not a 6502. It's a derivative of both of those. So most likely and almost certainly, without having a look at his letter here, what this does is it takes the regular 6502 with some additional logic chips, probably a GAL chip, like a 20 V8 or something. In fact, what does he write on here? Looks like he used a 16 V8 GAL chip, and that plus bus transceivers and a modern 6502 results in a working CPU for these machines. Awesome, awesome. That is so cool. At least 2 of my machines, if not more of them, have dead CPUs in them. 2 of them I've modified to use Commodore 64 CPUs, but that requires kernel modifications. So when you do something with this, it can work in a stock machine. Now the only thing I worry about is in a machine like the Plus/4 and probably the 116, there is not a lot of room. So I'll have to talk to Daniel through email, although his letters that he sent here are very lengthy here. In fact, yeah, here's a really long letter from him. So he probably talks exactly about what needs to be done to make it work. He has gone ahead and sent me an assembled one. There it is. And he has sent me, looks like 3 CPUs. It's hard to read. The markings are dim, but those are probably 6502s plus a couple gals that are programmed. So Daniel, as usual, has gone out of his way to make something incredible, and he's gone ahead and sent me these parts. So this is amazing. I'm really excited about this. There's one more thing here, and it's an Atari 6502 Sally replacement. So the Atari 2600, if I recall, or maybe it's the 8-bit computers. I have to read up. I'm not super familiar with Atari stuff, but I know they use a variant of the 6502 that is very bespoke for those machines, and it's called the Sally, and you can't just use a regular 6502. So again, he has there's a couple DIP ICs in here and probably a 6502, and you can replace that CPU as well. So this is incredible. This is absolutely incredible. So let's take a closer look at this stuff. All right, I think this is it. 8501 equivalent. And there it is, a Rockwell 6502. And then we have a GAL here. This is the extra logic. And I don't even know what those chips do. He probably explains, it looks like there's some letters and stuff here. So this has already got the little pins. It's got some stuff on the bottom as well. Oh, look what he says here. Daniel Mantioni from the Netherlands, April 2020. All right, well, Daniel, it's like more than 3 years later, and I haven't even shown this yet on the channel. Oh man, I feel so bad. I assumed this was from last year, like 2022. I didn't remember that. Oh, this isn't gonna fit here, is it? Well, that's not gonna work because I got the heatsink there on the TED. So I think what I'm gonna do is put the original CPU back in, and we're gonna swap over to this TED right here. And I think without the heatsink situation on here, there should be enough room for the CPU, maybe. All right, that was a bit hard to get in there because the pins were all bent and those sockets are not forgiving for that. Do we have a working system? These chips are, it works. Okay, great. These are very, very failure prone as well. So while we have it, I'm just gonna put a check mark on there, say that it works. All right, and let's get the CPU out. Let's see if we can use Daniel's little interposer board here. Oh, it's got a little bent pin going on it too. Just from transport, I guess. All right, well, I think it's in there. I'm gonna push down on it. Let's see if this, whoa! What happened? We lost everything. That was weird. I don't understand why that would happen, but it's freaking working. If I let go, oh, it's still working. Okay, great. Let's hold the reset and switch into NTSC mode. Think we're good. Let's see what happens. I don't understand why it all blanked out. That doesn't make any sense. There we are. We're in. Oh, the keyboard's not working because it's not plugged in. We are in NTSC mode. Daniel's replacement CPU board is working. So if you have any of these TED machines that aren't working, let's see if he included instructions and stuff here. He sent me a whole bunch of stuff here. It's all pretty sweet. Oh, look. Oh, yeah, I forgot. He has a Sally replacement as well that works in a very similar way to this. So this is for the Atari machines, with also have a slightly custom processor. The Sally was used in the Commodore 800 XL and also the 65XC and 130XE. It does like round the banking or whatever. And the resulting CPU conflicts with the RF shield. Okay, so obviously, I don't know, this is from years ago, right? He might have even refined it since then. Pause the video here if you want to read the text here about how the Sally works, but he kind of talks about how it works. And there's assembly instructions. There it is. There's a couple logic chips in there. And then we have this, the 6529 single port interface replacement. What is this used in? Oh, this is the CIA for these machines. Right. Daniel is just rocking it with all these things. Where is it on this? Oh, it's a little chip, if I recall. He's pointing to it here in this little photograph. It's like one of these chips, and it's a custom chip. It's a 6529. And without it, you're not going to have a working Commodore +4 TED machine. So there's some assembly instructions here. And I guess there's the little board or jumper settings. There's the little board right there. This stuff is absolutely amazing. Let's see what else we got here. Precision sockets. Yeah, because when you plug this in, it can damage your sockets. Here is the Sally replacement. Let's take a look at that board. Looks like everything is socketed, so obviously you just use a regular 6502 in there, not the, you do not use a C02, you can use 6502C. Different, that's different. The C is the new version. None of this stuff is soldered on here, but that's cool. It's all together, and then he included the little logic chips there, so 6502C Sally replacement. I know here there's some chips. Let's zoom in a little more so I can see what these are. 6502A and another 6502A. And I don't know what this is. 63OP. Is this some kind of like clone 6502 or something? And then we have 5801 CPU controller. That's this chip right here. That's the gal that controls the CPU. Here is the 6520 replacement that is for this machine, so you can get your I/O ports working again if those go bad. Looks like here we have a couple of the boards here, the 8501 equivalent boards. Everything that Daniel does is going to be available to download for free from his website, so I will link to that. So if you need to make stuff like this, you absolutely can. And faster set of chips for the 8501. Interesting. I wonder if sometimes there are problems with the chips on here and you need these F versions. Is that an F version? Yeah, an FCT. So fast. Okay, what's this here? Commodore +4 replacement. Okay, yeah, this right here is the PLA, which if I zoom out here is installed already. I don't even know if I've ever done a video about it, but this is the PLA for this machine. I must have been testing it. I think this is the one he probably sent with this stuff that I've had for years. And let's see what else here. We have a bunch of nice pins that he sent. Thank you very much for that, Daniel. And then we have this. There it is. That's the PLA 20V8 Model B. So that is this right here. That is super cool. These are all chips that are impossible to find. And then this looks like another one of those CPU adapters. He sent me several of these because I think I have like 2 or 3 machines that have bad CPUs. In fact, this machine right here had a bad CPU that kept it from working, but a viewer sent in this CPU here and gave this to me, so that got this up and running. But yeah, I have, looks like 3 more of these kits to build replacement CPUs. But look, how freaking cool is that? So all commodity parts here. It's not like they make these particular 6502s anymore, and they don't really make these types of gal chips anymore, but still very, very commonly and easily available. And then you have a freaking working machine. The TED is the one that is not replaceable. If you have a bad TED, you're gonna have to try to source another one of those. That's a very custom chip. But this and the PLA and then the IO chip, which if it moves over here, I don't know, it's one of these little chips over here. Zoom out a little bit. Yeah, it's like, I don't know, it's one of these over here. That does the I/O, and you need that to work. Well, as you just saw in the unboxing, I had the letter from Daniel, but I seem to have misplaced it since then. So luckily he had a copy of it, so he sent it over to me, and that's what we are looking at here. But he goes on to say that here's the 8501 CPU replacement. That's the TED CPU replacement, and it took him several revisions to get this working because it just took a while to get each of the fixed PCBs from China. His goal was really to create something that was relatively low cost. Of course, it does result in the complexity of those multiple surface mount chips on it. And then he goes on to talk about the fact that included in this package are a couple different sets of chips. We have fast ones and slower chips. The original idea was the fast chips might be better because the original 8501 does not need to account for the delay of external chips. I built a CPU with slower components to challenge the design and used HC chips with CMOS logic levels to make it more challenging. The result was opposite of what I expected. Both chips result in a working CPU. However, I have one C16 board upgraded to 64K with Samsung memory, and that makes complex games crash. The fast chips work fine in the other boards, and if I swap in the Samsung memory back with the original 16K Fujitsu memory, the board works fine as well. However, the slower HC chips have perfect results until now and work in everything. Well, that's fascinating. I've included a selection of 6502 CPUs in the package from MOS and Rockwell, and one of my more peculiar ones, a CM630P. This is a relic from the Cold War and a result of Bulgarian spies stealing the 6502 design. They were used in the Bulgarian Pravits 8D computer, which is a clone of the French Auric Armos computer. I've read reports of people who have decapped them, and they are an exact clone of the MOS 6502. Even the initials of the original designers are reported to be on the die. The C630P is not extremely rare, but is still a nice item to have in your CPU collection and teaches a bit about computer history on the other side of the Iron Curtain. It works just as well as any other 6502 and supports all the undocumented opcodes. Well, yeah, if the die is a clone, of course, that's kind of a given, but that's well, I guess it's not a given, but that's pretty cool. There should be no need to experiment with different 6502 boards on the 8502 replacement. All the different 6502s get me perfect compatibility results. After you've installed the new CPU in your C16 or Plus 4, be sure to try one of the more advanced Plus 4 games such as Pets Rescue or Alpha Ray. The main advantage of the 6502 base CPU replacement compared to 6510 CPU replacement at these games will work. The main advantage of the 6502 base CPU replacement compared to the 6510 one, that's the one I referenced in the unboxing that I had done previously. That's the C64 CPU and requires a modified kernel to even work. Well, it will boot up the system, but you won't have working disk drives or tape drives, if I recall. These games will work with this new CPU replacement, and that's a big deal for their usability. The 6510 works fine, you know, if you're just going to do some casual basic and stuff like that, but it's just not great for full compatibility. As soon as you install the proper 6502 base replacement, you're able to play more advanced games, and the computer becomes suddenly a nice, usable retro machine. Yeah, I did have problems with the 6510 replacement and a bunch of games. They just don't work correctly because as soon as they start to load, it takes over from the kernel routines, which need to be modified to work with the 6510 for the disk drive access. And as soon as those games try to use like a fast loader, they fail immediately because the IO ports are different for the disk access. Also included is the PLA replacement, the PLA 16V8. The bottleneck with the TED is clearly the CPU. That's the ones that fail, really. Not really. Well, I've never had a PLA fail on these machines, so it's still nice that we have a good replacement. And I think there have been some other ones as well that were more expensive because they use CPLDs, but the PLA based version is really good. And as you notice, in my C16, I actually have Daniel's PLA in there, and I don't remember why. I think I was just testing it. I don't think my PLA actually failed. Anyhow, he does say that that single GAL 16V8 does work, and you just need a couple diodes. That's unlike the C64, which requires 2 of them. And then he goes on to talk about the MOS 6529 single port interface that's also found in the TED series. The motivation is the same. While shortage of the SPIs is not severe as the CPU storage, I saw the opportunity to replace the SPI with 74 or whatever 654, something I haven't seen anyone do. In fact, there are many misleading recipes on the internet to replace the 6529. I took the opportunity to design a proper replacement. And looking at the big picture, all that's left for these machines that is hard to find is the TED chip itself. That's the graphics and sound chip. All other components now become replaceable without weird parts. How freaking fantastic. FPGA TED, I guess, project is combining my work with his work and should become possible to build an entirely new TED computer from discrete parts. So I guess there's an FPGA TED replacement that is coming, and that means literally reproduction motherboard and all modern parts. Well, modern and in that, you know, you need a 6502, you need these GAL chips, which are kind of older, but they're just not rare and they're ultra common. The next thing included in the package, the PLA 20V8 Model B. The original one works well, but doesn't stop me from doing further research. It's based on a mechanical rewrite of the 64 PLA equations, which significantly reduce the logic required on the GALs and significantly reduce the number of traces on the PCB. The PLA works just like the original PLA 20V8. It gets good results during testing. The main question is if there is any practical advantage to the new PLA. There are a few macro cells free, which if necessary can be used to generate more delays. Another possibility is the new design makes possible that it is possible to clock all the outputs by the CAS line, a fundamental solution to eliminate switching noises. But the original PLA 20V8 did not suffer from them anyways. And he just goes on to talk about some of the differences with the new design. And then finally, we have the Atari Sally replacement. Basically, the recipe for the 8501 replacement can be used to build other CPU replacements, such as the 6510, the 8502, and the 6502C Sally. Because I own an Atari computer that had a broken CPU, I did start with the Sally. The included CPU should be considered a prototype. It needs further revisions, but it will work. And then Daniel goes into talk about that he sent some awesome little cookies and things like that. And yeah, all of that food was open way back in 2021, and it is long gone. I ate it right away, so nothing spoiled there. Thank you very much, Daniel, for all those candies. And lastly, he says that even though the package wasn't very big, it packed a mighty punch. And yes, it did. There were so many good things in there and so many awesome things for the community. Sorry it took me so long to get to it. So Daniel has gone ahead and made a whole slew of replacement parts for this thing to keep your TED machines, your Commodore 264 series machines up and running. And with my little mod here, you can switch between PAL and NTSC super easily. And we have a working TED chip and we have a working CPU here from Jeffrey today. So that's freaking great. In fact, all the chips that Jeffrey sent in today work. I'm not going to test the C128 ones because I don't have one handy that's taken apart like this, but this is freaking amazing. Not to mention this stuff here that Daniel has is freaking amazing. So I'll put a link below in the description for Daniel's webpage so you can look at his CPU replacement and the Sally replacement and the PLA here and the IO replacement. And of course, the Commodore 64 GAL replacement, which Daniel was the one who pioneered that way of replacing the GALs on the 64 instead of using CPLDs, which you can't even buy anymore. Those things are all like end of life. So essentially, Daniel's GAL PLA is the best solution for a PLA for your 64, and it's widely available because Daniel makes everything available for free. Daniel is such a nice guy, and he just contributes so much to the Commodore community. Really, hats off to him for doing all this stuff and for making it all free and not making it something you have to pay a bunch of money for. So I think it's time to end this video. Thank you very much, Jeffrey, for sending in these awesome chips for the Commodore machines. And of course, thank you, Daniel, for sending in these awesome projects and working on this stuff. And I'm so sorry for not having shown it on the channel for so long. Yeah, I wrote, that is wild. It is 3 years later. That's how backlogged I am with some mail call stuff. And then thank you, Steve, for sending all the Apple II stuff that you rescued and saved all those years and sent into the basement. Absolutely phenomenal. To have a ROM 3 2GS motherboard is amazing. Those things are not common, especially, you know, ones that are outside of a computer. If it's a full computer, that's one thing, but this one was not pillaged from a computer. It just existed on its own. Thank you for Apple stock in an old computer store that was an authorized Apple repair place. Anyways, that's going to be it. If you like this video, thumbs up. If you didn't, you know what to do. Huge thanks to my patrons. They make it all possible that I do this full time now. Their names are scrolling on the side of the screen. Welcome to all the new patrons. There were so many that came in a few weeks ago, and it's just absolutely staggering the support that I'm getting, and it just warms my heart. So thank you so much, everyone, for that. And you can become a patron if you want. There's a link down below, and you get early access to videos and behind the scenes things like that. That's it. Thumbs up, subscribe, all the usual YouTube junk, and thanks very much for watching. Stay healthy, stay safe, and I'll see you next time. Bye.